Hiya folks, this is question 4. So we're just gonna, so it tells us that z1, so it tells us that this is a root of z squared plus 3 minus 2i z plus p equals 0. So we're just going to put it straight in, we're just going to sub it in instead of z. So we get 1 plus I squared, so that's just 1 plus I, 1 plus I, plus 3 minus 2i times by z, so that's times by 1 plus I, plus p is equal to 0. So you can go off, you can do the box method there if you want for multiplying out double brackets. You probably won't need to. So 1 plus, you'll end up getting 1 plus I plus I plus I squared. So 1 plus 2i plus I squared plus 3 yeah, so then 3 times I will be 3i minus 2i times 1 is minus 2i, so you get 3i minus 2i, so that's just going to be plus I or plus 1i minus 2i squared plus p is equal to 0. Wherever you see an I squared in complex numbers, it always becomes minus 1, so you can put in a minus 1 instead of I squared everywhere in complex numbers. That's given to you in the question even at the start as well. So we get 1 plus 2i minus 1 plus 3 plus I minus 2 multiplied by minus 1 will be plus 2 plus p equals 0. Those will cancel. We get 3 plus 2, which is 5. We get 2i plus I, which is 3i. Just making sure I didn't have anything else. So then we get p is equal to minus 5 minus 3i. And that should be it for part A. Right, second part then, you have to use the Myers theorem. So let's just draw out where this complex number is then, just to visualize it. So it's minus 1 plus root 3. So it'll be up here in the second quadrant. So we'll just put it up there. So so this will be 1, okay, to get us out to minus 1, and then this, it goes up root 3. So that's it on the Argand diagram. So yeah, so R then, so we're going to be putting this into polar form. So R will be equal to square root, so we're finding the modulus, so it'll be root 3 squared plus 1 squared, and ultimately yeah, root 3 squared will be 3, 1 squared will be 1, so it'll be 3 plus 1, which is 4, so it'll be root 4, which is 2. So R will be 2 here. So we're going to be putting it into this in ultimately anyway. The other thing we can work out is the angle, the theta. So you can do that in calculator or use log tables or whatever. So opposite adjacent, so it'll be tan inverse root 3 over 1. So we'll get 60 there. So 60 is our reference angle. So all the way from here to here then is 120, obviously. So theta will be 120. So it's always from here basically that we measure from. So 60 was reference angle, so their theta has to be the 120. So let's just see what the complex number. So w squared is equal to Yeah, so it'll be 2, because 2 is r, cos, and then we're putting in the angle. Now what you have to do here is you have to put in the general form for the Myers theorem. So it'll be or theta was 120, you have to put plus 360 n, and that allows for the other times that we go around basically. So if we only put in 120 there, it can only be this, but you can go around again and get should be 360 actually. Yeah, you can go a full circle around again basically and get whatever 360 added to it is. So you can, whatever angle is, so 120 plus 360, so that's 480, and then if you go on another 360 again, so that's just allowing for all of those, so you have to put in that. Plus I sine, and same thing again, 120 plus, I don't know, space here, 360 n, okay. Right. The Myers theorem then allows us to move this 2 in, or kind of square root the right hand side there. So W will equal, so this is what it says, that will become a 2, and then what happens is that the 2 goes in, and so really it's to the power of a half, so it should be a half in there, if you can see in there that I drew it in. So it's to the power of a half, so the half actually goes in and gets multiplied by the angle. Okay, so you're going to multiply a half by that and by that. So we get cos of, and if you multiply it by a half or divided by 2, it's 60 plus 180 is half of 360, n plus I sine, same thing again, 60 plus 180 n. Okay. Right, so then we just need to sub in values for n. So if n was 0, so for the first time you go around, so root 2, well, what's going to be, you can just put it all in, you can just sub it all in together. Well, yeah, you'll get root 2, and then you'll get a half plus root 3 over 2i, and then that's just going to be equal to root 3 over 2, or sorry, root 2 over 2 plus root 6 over 2i. And then if we go and we put a 1 in instead of n, so we get root 2, and we get minus a half, yeah, when you put in the angle, that's the way it works out, minus root 3 over 2i. So we're getting the negative of it, basically. We're just getting the negative of what W 0 was. So it'll be minus root 2 over 2 minus root 6 over 2 I, and then that's all we need to do then. So that's part B. Right, so last one then, or part C. So you're just given a complex number a plus bi, so you're not told what it is. So you need to know that the line above it is conjugate, and you need to, yeah, it's not, I don't think it's the worst type of question. I think you can figure it out even if you haven't looked at this for a while. I don't think there's been much like this for the last couple of years, I don't think anyway. Right, so you have to work out what IU is anyway, so this should be nice enough, should be straightforward. So you just have to do I multiplied by A plus BI. So that's just AI plus BI squared. And then you know that, we said earlier, anywhere you see an I squared, you can change it into a minus 1. So that'll become a minus 1, so you get AI minus B. And that's the same as minus B plus AI. Okay. Conjugate of it then, that's what the little line above it, that's what that line there means. All you have to do for conjugate is just change the sign of the I term, or generally the second part. So that'll just be minus b, instead of plus it becomes a minus, so minus b minus ai, and that's all you have to do for the first part of it. Second part, plot and label the complex numbers IU and conjugate of IU. So let's go IU anyway. So IU is minus b plus AI. So in the diagram, this distance out here has to be A, and then this distance up here has to be B. So therefore we're going minus B, therefore we need to go a longer distance, so we need to go out to here and then down, it's minus B plus AI, so it's the same, we have to go up the same from there, the same distance as we kind of gone out here. So it should be about here. You can measure it in the exam anyway. So that's going to be IU. Now, second part is the conjugate of it. So the conjugate will always be flipping it over the axis, basically. If you don't know that, you can think about it anyway. So you go out, you go minus B, so you go out the long distance again, but then it's minus A, minus AI, so it'll be down here. So that'll be it. So it'll be conjugate of IU. So that's it. And it says as accurately as possible, so you won't be penalized too much if you don't have it exactly. So state a transformation or series of transformations that would send U to IU. Do not include a translation in your answer. Yeah, so well, you just have to think about it, what's actually happened, or yeah. So if you're starting here, if you just pretend that you're here now, and then you're moving all the way over to here, what have you done? Well, it's been a rotation 90 degrees anti-clockwise. So you've rotated anti-clockwise, so you've gone this way, okay, to get to there. So that's the first part of it. So rotation 90 degrees anti-clockwise, and then the second part of it is that once you've got to that point, once you've got to IU, to get to conjugate of IU, you've got, it's a reflection about the x-axis, so it's a reflection over the x-axis. So then a reflection about the x-axis. So that's it. I don't think it was too bad of a question overall. You have to understand the Myers theorem. Part A was okay. The last part, you should have been able to get most of it really. And then then the Myers theorem in the middle you need to understand, but that comes up nearly every year anyway. So that's it. That's all for that question.